Hello everyone and welcome to your lesson of physics. In this video, I'm solving the worksheet of chapter number 1, AS Physics. So let's start off with the first one. The question I'll be speeding up in this video. We'll try to solve the question as fast as possible. Which row shows what all the physical quantities must have? So physical quantity, they must have magnitude and unit. Direction is optional. If they don't have a direction, they can still be a scalar quantity. They can still be a physical quantity. Let's take a look at the second one. What is the alternate way of expressing an energy of 43 decijoules? Small d here stands for decijoules. So what you can do in these kind of questions is get rid of all the prefixes and then equate the answer, then equate the given value with all the options. So if I get rid of the prefix, which is deci here, so it would be 43 times 10 raised to the power minus 1, okay, which would be 4.3. You can just hit it on the calculator, or simple mathematics gives you 4.3 joules. So if I crack the first one, the very first one, and I try to get rid of the prefix here, so it would be 4.3 into 10 raised to the power 3. And then what is the prefix? What is the exponent for the prefix milli? It is 10 raised to the power negative 3. So times 10 raised to the power negative 3 joules. So you see these two things would be cancelled out and you'll be left with 4.3. So the very first option is the right answer. Now if you're wondering how do we cross out 10 raised to the power 3 and 10 raised to the power minus 3, check it out. 10 raised to the power 3 times 10 raised to the power negative 3. Now you use the laws of indices. So what do you get? 3 minus 3, so 10 raised to the power 0, which is 1. So 4.3 times 1 would be 4.3. So the very first option is the right answer for question number 2. Alright, let's take a look at the next one. So what is the average thickness of one sheet of paper in the block? So the reading starts from 0.9 and it ends at 3.6. So what is the difference between these two? We get 2.7 centimeters. All the options are given in millimeters, so I can convert into millimeters first. 27 millimeters. So 2.7 from centimeter, if you try to convert into millimeters, you will get 27 millimeters. Just use the same rules of prefixes that I explained previously, that you need to convert, you need to get rid of centimeters and you need to add millimeters. So in principle, according to that rule, you'll be getting 10 raised to the power minus 2 over here. And what is the prefix for milli? 10 raised to the power negative 3. And you hit this thing on the calculator, you'll be getting 27. So 27 millimeters is the thickness for 210 sheets of paper. But we are asked to find the thickness of one sheet of paper. So what do? 27 millimeters divided by 210. You hit it on the calculator. In 2SF, you'll be getting C as the right answer. In 2SF. Okay, so the closest option, 0.126, it would be 0.126 something. You round it off to 2SF, you'll be getting 0.13 millimeters. What is the unit of resistance when expressed in SI base unit? So resistance, the formula that we have is V over I. We study this equation as Ohm's law in IGCSE and O-level physics. Now what does voltage equals to? Voltage equals to W over Q, work done per unit charge. Now what do we have for the work done? We have kg meter square per second square. How do we get it? W equals to F dot D. You can get it from there. Otherwise, I tell the students that try to memorize the base units of the work done. Now for Q, charge would be AS. The same class that you're studying right now. Q equals to IT. From there we get amperes times seconds. So we write it as it is, kg meter square S minus 2 divided by A times S times the unit of current for this one, because these are the base units for voltage, and then the second one is the base unit for current from here. So you sort out all of it. So what do you get? You get kilograms, then you get meter square, you have s raised to the power 1 at the bottom, so it'll be total of s raised to the power minus 3. Then you have ampere square in the denominator, which can be written as a raised to the power negative 2. So D would be the right option for this one. Now, which graph shows that there were random errors in the measurement of P and Q? If there are random errors, then the values or the measurements would be scattered around the mean value. So that's why I will be drawing the line of best fit. So C is the right option for this one, because your values would be scattered all over the line. Let's take a look at the next one. What is the SI base unit of force? kg ms minus 2, F equals to ma, but you gotta memorize this one once again. Then we need to find the base units of epsilon, this thing. Use the above expression to determine the base units of epsilon. Okay, so what you can do is we can rearrange this thing with force. Okay, this is a problematic student, so I'm going to switch the seat of this student with force, and everything else, all other students would stay on their places. So q1 q2 divided by 4 pi r square, then you get F over here and epsilon over here. You can call it E for the time being if you want. In the next step, I'm going to ignore all the constant numbers because they don't have any unit. Then I'm going to insert the units. For Q1 we get AS, okay, the same one, AS for charge. For the second charge we get the same AS divided by, for square of distance we get meter square. For force we get kg ms minus 2. Now we can do some cancellation. For example, what we'll be getting is a square, ampere square, kg minus 1, because you have only one, you have kilogram isolated in the denominator. If you shift it upward, it would be k raised to the power negative 1, kg raised to the power negative 1. Then what about the meters? So you have a total of meter cube in the denominator. If you shift it upstairs, so you'll be getting m minus 3. Now what about the seconds? So we have seconds over here. If I combine these two, I get second square at the numerator, and in the denominator I have s negative 2. So the negative 2 once shifted upward would be plus 2, so I get a total of s raised to the power 4. So the final answer for this one would be A2 kg minus 1 m minus 3 s raised to the power 4. The order is not important. You can write in any order, but the exponents have to be exactly the same. Alright, moving on to the next one. We're going to speed up from here. What is meant by the systematic error? So systematic error is the error due to fault in the system, and the system includes the apparatus, the procedure, the equation. The random error, it is the error due to fluctuations in the environment. For example, the temperature, change in temperature, atmospheric pressure, wind, humidity. So these kind of things, or even parallax error. So this is for the random error. Okay, so you can just note down the definitions, the ones that I've just stated. Let's move on to the next one. The potential difference across a resistor is measured as this much. The resistor is labeled as resistance of 125 ohm plus minus 3%. Calculate the power dissipated by the resistor. So you're provided with a formula. I provided the formula here because at this stage you may not have may not be able to recall it, so I've written here anyway. So power equals to the square of voltage divided by the resistance. In the first part they have just asked you to calculate the principal value. Okay, so just calculate the principal value, not the uncertainty. Uncertainty they have not asked for now. So what do you get? You get 25 divided by 125. So you get 1 over 5, which you get 0.2. And I'm going to write the answer in the least number of significant figures, which is 2. So 0.2 would be written as 0.20. So this is a very common mistake. Many of the students would be tempted to write 0.2 as the right answer, but you have to write your answer in 2 significant figures because the least number of significant figures are 2. Okay, then they ask you to calculate the percentage uncertainty in the calculated power. So the formula is P equals to V square over R. So we need to find the uncertainty in V square, and we need to find the percentage uncertainty in R. So the percentage uncertainty in resistance is given already, 3%. Okay, so the percentage uncertainty in radius is given as 3%. Another mistake is many of the students, they'll be trying to find the percentage uncertainty in resistance like 3 divided by 125 times 100. No, you're already given with the percentage uncertainty, so not needed or not required to find the percentage uncertainty once again. So what you get is 3% will be the percentage uncertainty of resistance, but you are required to find the percentage uncertainty of voltage, and then you have to multiply it by 2 because you have V square. So V square means V times V. So what do we get for the percentage uncertainty of voltage? 0.1 divided by 5 multiplied by 100. So what do you get? You get 10 divided by 5, which is 2. So 2 times of that much would be 4%. So what is the total percentage uncertainty? 7%. Okay, then for the last part of it, determine the value of the power, whether it's absolute uncertainty, to appropriate number of significant figures. So the value of power was 0.20, and the percentage uncertainty was 7%, but we need to find the absolute uncertainty. So we'll be converting the percentage uncertainty into absolute uncertainty. How? Just find 7% of this thing. So what do you get? 0.20 times 7 divided by 100, and what you'll be getting is 0.014, 0.014. So the final answer for this one would be 0.20 plus minus 0.014. But if you leave your answer like this, you see rule number 1 of writing the uncertainty with the principal value is violated. So there's violation of the rule number 1. The rule number 1 says the number of decimal places in the uncertainty cannot exceed the number of decimal places in the principal value. So you have 3 decimal places here in uncertainty. So you need to get rid of one of the last one. So if I remove 4 from here, it would be no effect on 1 because the number that we have removed was less than 5. So this would be the final answer, 0.20 plus minus 0.01. So let's move on to the next one. So the speed of sound is given by this expression. We need to find the value of k using the data. So v equals to, I'm going to take square on both sides in order to get rid of the square root sign. So v square equals to kp over rho. So what is k equals to? You can rearrange the expression to find the value of k. K would be equals to v square rho divided by p. What is the next step? You need to find the value of k, you need to find the principal value. They haven't asked for the uncertainty, so you need to ignore this column. Just insert the values here, which would be 3.3 into 10 to the power 2, but then square of it times 1.29 divided by 9.9 into 10 to the power 4. So what do you do from here? Just hit it, write it as it is on the calculator and find the value of k. So the value of k would be 1.412, something like this. But you see, what are the least number of significant figures in the data? 2 here, 2 here, 3 here. So what is the least number of significant figures? 2. So your final answer has to be in the least number of significant figures of the raw data, which is 2. So in 2SF, the value would be 1.4. Let's take a look at the next one. Now use your answer to determine the value of k. Okay, the value of k is we already know now 1.4 with its absolute uncertainty, and give your answer to appropriate number of significant figures. Alright, so all we gotta do is find the total percentage uncertainties, because the quantities were being multiplied or divided in the formula of k. Then we can find the absolute uncertainty from that percentage uncertainty, and then we can write the final answer with the appropriate number of significant figures. So let us find the total percentage uncertainty. So what is the formula for k? If you rearrange it for k, we get this thing. So how many quantities do we have for this thing? We have v square, means we need to find the percentage uncertainty of v, speed, and then we need to multiply it by 2 because the exponent is 2. Then we need to find the percentage uncertainty of rho, the density. Then we need to find the percentage uncertainty of pressure. Then we need to add all the percentage uncertainties. So what is the percentage uncertainty of v? It is already given. All we gotta do is to multiply it by 2 because we have v square. So the total percentage uncertainty of v would be 6%, plus for rho it is 2%, plus for pressure it is 4%. So 6 plus 4, 10, 10 plus 2, 12. So we get 12% total, a total of 12%. But we need to find the absolute uncertainty. Alright, we need to find the absolute uncertainty. It's mentioned in the question. So you can't leave your answer like this. So all you gotta do is find how much 12% of 1.4 is. How do we do that? Simple mathematics. 1.4 times 12% means 1.4 times 12 divided by 100. So if you hit it on the calculator, you'll be getting 0.17. So you write your final answer as 1.4 plus minus 0.17. But then you realize this thing, that the rule number 1 of writing the uncertainty with the principal value is once again violated. Why? Because you have 2 decimal places here, but over here you have a single decimal place. So you need to get rid of one of the decimal places from the uncertainty. If I round it off to 1 decimal place, it would be written as 0.2 instead of 0.17. Let's take a look at the next one. Determine the SI base units of K. What are the quantities? F is a force, V is the speed, A is a cross-sectional area given in the question. You can just read it out by yourself. So the units of K, I'm going to make K the subject divided by V square over area. So what are the base units for force? Any kind of force, the base units would be same, kg ms minus 2. What are the base units for speed? Meter per second. But you have the square of speed. So what do you get? You get meter square per second square. So m2 s minus 2. Now what are the units for area? Meter square. Now let's do some cancellation. S minus 2 cancelled out, and what are you left with? You're left with kilograms, and you have meters at the top and M4 at the bottom. So if you combine these using the laws of indices, you get M1 minus 4, which is m raised to the power negative 3. So kgm minus 3 are the base units of this quantity, which are the base units for density. Okay, then we have the part B. Describe what is meant by high precision. So high precision means the measured values are close to one another. Now how do we define the low accuracy? So accuracy is how close the values are compared to the true values. So low accuracy means the measured values are not close to the true values. Alright, let's check out the last one. So you're given with the value of length. Okay, length of the pebble. R is the radius, the maximum radius. M is the mass of the pebble. State the name of the measuring instrument suitable for making this measurement of length. Okay, so let's check out the uncertainty. Okay, you can also check out the number of decimal places, or you can check out from here the number of decimal places that you have. So here you have 1 2 3 4 decimal places in meters. So what do you get? Yeah, 0.0001. Okay, you have 4 decimal places in meters. So I'm going to convert it into millimeters. So I can multiply it by 1000, and we'll be getting 0.1. Multiply by 1000, so you get 0.1 millimeters. Now what is the instrument that is able to measure to 10th part of a millimeter? Some of the students write meter rule as the answer, but meter rule can only measure to 1 millimeter, not less than that. The least count of the meter rule is 1 millimeter. So the instrument that is able to measure 0.1 millimeter is vernier calipers. You can check out the spelling. Okay, the next part is determine the percentage uncertainty in the measurement of R, and that is only for a single mark. So what do we do is we are given with the absolute uncertainty of R, we are given with the principal value, so we can just divide the absolute uncertainty by the principal value 0.0420, and we can multiply by 100. We'll be getting the percentage uncertainty of R, and we'll be writing the answer to one significant figure, and it would be 1. Okay, so if you have to write the percentage uncertainty and they have not imposed any limit on the number of significant figures or on the number of decimal places, so you leave the answer to 1 SF. Let's check out the next one. Use SI base units to show that n is equal to negative of 2. So I'm going to insert the unit straight away. For rho, we have rho is the density given in the question. So the base units of density are kgm minus 3 equals capital M is the mass, so kilograms. R is the radius, so meters, but raised to the power n. Okay, and this whole thing divided by k. K is a constant number with no unit, so I'm going to get rid of k, it's not even there, and divided by length. So length, the base unit would be meters. So what do we do from here? Some of the cancellation, okay, like kilograms cancelled out by kilograms. This meters would be shifted on the other side, it would be multiplied, so we get meters, we get meters into m raised to the power negative 3 equals to m raised to the power n. So what do we get on the left side? We get m raised to the power 1 minus 3. So m raised to the power negative 2 equals to m raised to the power n. So the bases are same, then we can equate the exponents as well, so the value of n appears to be -2, and we have to show this. Now in the next part we need to find the percentage uncertainty in rho. Alright, so you can make rho the subject. It is already the subject. I'm going to rewrite the equation. So rho equals to m r raised to the power -2 divided by KL. So for the uncertainty, you're going to get rid of the constant number. It has no role in the calculation of the uncertainty, so it's not even there. Now from here, the students know this thing, that whenever you have the quantities being divided, you need to add the percentage uncertainties. But the mistake is, many of the students, because they would see the exponent of r as -2, so they'll multiply the percentage uncertainty of radius of r by -2. That's not the case. So you see, what you can do is you can rewrite the same equation. In uncertainty, we don't multiply with the negative exponent, because you can write the same thing as this, m over L, and instead of r raised to the power -2, if you write it in denominator, it would be written like this. Now whether the quantity is being divided or multiplied, you always add the percentage uncertainty. Or even if you don't write it like this, still you'll be just multiplying with the exponent irrespective of the sign of the exponent. So you'll be multiplying the percentage uncertainty of r by 2, not with -2. So the percentage uncertainty of m is how much? Okay, we need to find the percentage uncertainty of m. So the percentage uncertainty of m would be 0.001 divided by 1.072 times 100. And the percentage uncertainty of r we calculated already. It was 1%. And the percentage uncertainty of length would be 0.0001 divided by 0.1242 times 100. The only thing that you need to do is the percentage uncertainty of radius would be multiplied by 2. So the percentage uncertainty for mass plus the percentage uncertainty of length plus 2 times the percentage uncertainty of r. So you'll be getting a total of 2% in one SF. Okay, like I said, if they haven't imposed any condition, so you better be writing your answer to single significant figure. So you get 2 from here. Okay, and then for the last part, determine rho, whether it's absolute uncertainty, give your values to appropriate number of significant figures. So in order to find the value of rho, you need to find the principal value. So you rewrite the formula, m raised to the power r raised to the power -2 divided by L. You can even shift r raised to the power -2 in the denominator, and you're left with m divided by r square into L. But since you can use the calculator, so you can write the negative exponent. Calculator would do all the work. So what is the principal value of m? It is 1.072. What is the value of r principal value? 0.0420. 0.0420 raised to the power -2. You can add the negative power in calculator. It's not difficult. So what is length principal value? 0.1242. Okay, so you first press the fraction button, insert all the values as it is, and hit the answer button. So you'll be getting in 4SF, you'll be getting the answer 2337. All right, plus minus 2%. But you need to give your uncertainty as an absolute uncertainty. So all you can do is find how much or what is 2% of this thing. So once again, the same method, 2337 times 2 divided by 100. You'll be getting 2% of this thing, which in 2SF would be, if you round it off, would be 49. So all the absolute uncertainties in the measured value in the raw data were given in one significant figure. So your uncertainty, absolute uncertainty in one significant figure from 49 would be written as 50. And the final thing, some of you might be wondering, why do we write the principal value? Why do we write the final answer principal value in 3 significant figures? For example, why do we leave the final answer in 4 significant figures? For example, 2337. The thing is, because you have to refer to least number of significant figures in the raw data. If I show you the raw data from here, you see the least number of significant figures in the principal value are in this one. How much? 4203. You have 3 significant figures, so the least number of significant figures are 3. Here you have 4, here you have 4, but for the middle value you have 3. So you'll go with 3 significant figures as for the principal value as well, because the strength of your team depends on the weakest player, not on the strongest player. So the chain is as strong as the weakest link. So it is the weakest measurement that would determine number of significant figures in your principal value. So we'll go with 3 significant figures from that one.